Hello everyone, we are going to proceed and solve step by step this problem. As I said before, what we can see is that the mercury oxide thermally decomposes into mercury and oxygen. We have to write down that as a chemical formula. So that is mercury oxide is thermally decomposed into mercury and oxygen. Okay? Well, that's the first step. Second step is to balance the chemical reaction. To balance the chemical reaction, we, as usual, go first of all with the non-oxygen or hydrogen atoms, mercury here and mercury here. We have one atom of each one. And finally, oxygen. We have one here and we have two here. So what we have to do is to add a second one by multiplying the first molecule by 2, and that involves also multiplying the second mercury on the right hand side, and now we have two atoms of each species on both sides of the chemical equation. That's all right. After that, what we have to do is to calculate the number of moles of the information of the substance we are given. So in this case, we know that 2 liters of oxygen have been released at 273 degrees Celsius and 646 torr. So we know 2 liters, we know 273 degrees Celsius, and we know 646 torr. These can be transformed into Kelvin by adding 273 more, so that makes 546 Kelvin of temperature. For the pressure, we have to transform it into atmospheres by knowing that 1 atmosphere is equal to 760 torr. So we write it like a conversion factor in which 1 atmosphere is divided by 760 torr. In this way, we can make the torr and the torr disappear, and the final pressure will be 0.85 atmospheres. The other value that we need to know when we're working with gases is R, the constant of ideal gases, that is 0.082 atmospheres liter divided by Kelvin and mole. We know the equation of ideal gases that says that PV equals nRT, so we can work out N, that will be PV divided by RT. Therefore, that will be the pressure we take it from us. This is 0.85 multiplied by the volume, that is 2 liters. Sorry, that's 2 liters, and that divided by R 0.082. That makes that multiplied by 546. And that produces a number of mole of 0.038 mole of oxygen. So once we know the number of moles of oxygen, we can work out the number of moles of mercury oxide that have reacted with that. Therefore, 0.038 mole of oxygen by the ratio of stoichiometric coefficients will be equal to 1 mole of oxygen per each 2 moles of mercury oxide. That makes, again, we can work out the number of moles of mercury oxide by multiplying 0.038 multiplied by 2 and divided by 1, 0.076 mole of HgO. And the final step is mercury oxide is made of mercury, one atom of mercury that has an atomic mass of 200.5 grams per mole, and one atom of oxygen that has an atomic mass of 16 grams per mole. Therefore, the molecular mass of mercury oxide will be 216.5. Sorry. 216.5 grams per mole. If we know that the number of moles is equal to the mass divided by the molecular mass, then we have that 0.076 is equal to the mass divided by 216.5. Therefore, the mass will be equal to 0.76 by 216.5. I'm going to separate this. Therefore, the mass will be 16.45 grams of mercury oxide. And this is our result at the end of the problem. Thank you.